Hello. Today we are going to talk about even and odd functions. We already know their definitions. In fact, an even function has its graph symmetrical about the y-axis, which means that if I fold along this axis, two rays coincide. Algebraically means also that if I have an x here, a value of the x, whatever value, and I consider its opposite, negative x, their images are exactly the same, which means that f of negative x is exactly f of x. If we talk about odd functions, their graphs are symmetrical about the origin. They are symmetrical, which means that if I consider again a value of the x and its opposite, their images are opposite as well. I'm going to write it down. F of negative x is negative, the opposite of f of x. Now we are going to figure out when we have even or odd functions from the formula. And for that, we need to pay attention on these expressions because they are related to the algebraic expression of the function. So we'll work out the final expression of negative x, and after that we'll check if we obtain f of x or negative f of x. Okay, so we have three examples: f of x, g of x, and h of x. We are going to start with f of x. We need to obtain f of negative x, which means that I'm going to replace every x by negative x. We have negative x to the power of 4, which is an even exponent, so the result is positive, and I obtain x to the power of 4. And the same thing happens with negative x squared. I have negative 2 times x squared, positive x squared, plus 1. And as you see, we have obtained exactly the expression of f of x. So f is an even function. Let's go with g of negative x. 2 times negative x cubed minus 5 times negative x. And in this case, the exponents are odd numbers. So the sign is negative. So negative 2x cubed, and negative times negative is positive, positive 5x. If we compare the signs of this expression to the previous one, we realize that we are changing every single sign, which means that we obtain negative g of x, which implies that g is an odd function. Let's go with the last example. H of negative x is negative x squared plus negative x. Here we have an even power, which result is positive, and an odd power, which the result is negative. And if I compare the sign of both expressions, I realize that I don't have neither the same sign of h of x nor the opposite signs, which means that h it's not an odd or even function. Okay, do you already know why these kind of functions receive the name of even or odd functions? Just pay attention on the expression. Every even function has even exponents for the x. The independent term is x to the power of 0. On the other hand, every odd function has expression with even exponents for the x. This is a 1. So when we have a polynomial with even and odd exponents, obviously I don't have any kind of these two type of functions. So when we have a polynomial function, we already know if we have an even function, an odd function, or none of them, paying attention on the x exponents. If we have even exponents, all of them, including the independent term, we have an even function. On the other hand, if we have only odd exponents for the x, we have an odd function. And if we can see a mix of them, even and odd exponents for the x, I don't have any odd or even function. Okay, thank you so much.